Hi guys, so let's start with our second lab, which is read text in images, right? So this is very similar to the previous lab. We again have to create a computer vision resource. Then we have to do the same steps of getting the keys and endpoints, cloning the repository, activating virtual environment, going into and changing the .env file and pasting our keys and endpoint there. Then we have to import these namespaces. So these are the same namespaces: image analysis client, visual features. Then again, same way we have to create the credential and the service client, which is image analysis client. Then again, with the main function, we are calling analyze function. Only difference is, then in visual features we are putting visual features dot read here. So that is one of the difference. And then we are like starting with our actual code. So before starting the actual code also, I have prepared everything. So I have opened the read txt.py. Just have to put the namespaces here. So yeah, let's put the namespaces here. Let's initialize our client and authorize our AI client, right? So this is our endpoint and this is our client, right? So afterwards, we have to just copy this code. So it is also calling the same method, analyze method. We are just passing a different visual feature here in the list. That is a read one, right? So yeah, read text in an image. So yeah, I will just format it later. And then what we are doing is we are getting the read because it is a read function, right? As you can see here, here this is a read. So that's why what we will do, we will do result dot read. And in read, now we have to think about when we call the read, then what happens. First of all, it will go to the block. So blocks is a list. First of all, it will go to the blocks. So blocks is a list. So it dot list, right? As you can see here also. So if I go to the um, here in read result we have a list of blocks, right? At the moment, only one block is returned. So that is why we can use just zeroth index, right? Because only one block is returned at this moment. So this blocks is a list of detected text block, and this detected text block has lines in it, which is also a list of detected text lines. And this is basically have a text and has a bounding polygon and words. Note that this is bounding polygon. So because this is a bounding polygon, so it why is it a bounding polygon? The question arises. So the thing is, when we have a text, that text could be a diagonal text. So if we say diagonal text, maybe there will be like searches, right? So if there is a diagonal text and we try to fit a box, like here they are fitting a box, right? Then this will basically waste a lot of space. So I think you can see, like, let me just so this is a diagonal text, right? So it's very difficult to make a horizontal box. So whenever we create a box, that is a horizontal box. So we have to create this box like this, right? So that is the problem. Let me show you it by snipping it. So like, let's snip the tool. Let's use the snipping tool, right? So if I have to draw a box around this, not this, right? So let me see. So if I crop the image and I draw the box, so I have to just put this text in here, the bottom one. So this one. So for putting this text, I am wasting a lot of space. I could have put this in a different this text. So that is why in this case bounding polygon helps, because Bounding box wastes a lot of space. You can see there are like upper triangle and lower triangle. All of this space is wasted. If we could rotate our bounding box, but we cannot do that, right? So the thing is we use bounding polygon, right? So that is the whole reason of using here bounding polygon. Currently it only support quadrilaterals, but that is also okay. We can still have a diagonal quadrilateral, right? And then this is basically bounding polygon like bounding box, and this has two descriptions, the x coordinate and the y. So it would be a list of 7 xy, right? Not 7, 4 xy. Then the next thing is words. So in words we have detected text word, then word is also a list, and this word list has a single word has a text. It also has again a bounding polygon and a confidence score. So this has a confidence score. The word has confidence score, but the sentence did not have a confidence score. Rest of these text and bounding polygon, it was also in the sentence, right? So as you can see in the sentence also, it was the same thing. So this is uh, not the sentence. We can the line. They are calling line as a sentence, right? So this is a line, and also that makes sense because they are just capturing the line. They are not capturing the sentence using the full stop or something like that. They are just capturing the line. So this is the line and blocks. So by this we can understand here we are having a list of blocks, and in that list we are having a sentence. So if we say this for I in this, then we will see that I is basically list. So I is a list of blocks, but there is only one block, so we can use I0, right? Then this is a block. Now blocks has a list of lines, so we will call lines and we will call dot list because lines is again a list. So for lines in a list, now what does the lines contain? Line contains the text, so we can say text, and line also contains a uh, bounding polygon, right? So we can say bounding polygon, and the next thing it contains is again yeah, for next thing we have to loop it, which is j dot words. So words are again a list, that's why we have to loop it. And what each word contains, it also again contain text, it again contains bounding polygon, and the next thing that it contains is confidence score, right? So for that we have confidence. So this is the whole key here. So now if we see in the code, so what are we doing? Result dot read, we are checking whether it exists or not. So it's is it none or not. Then from the blocks 0 we are just extracting each line. So from lines we are getting each line, and we are printing the text at each line. And then this is the helper function we use, and we are passing everything here. So yeah, so this creates this kind of image in which each line is basically bounded with a bounded polygon, which is also quadrilateral of 4 points. As you can see here, this line in the temple, right? So this is not a complete line, so not a complete sentence in the temple. So it is basically creating lines, not sentences, right? Then adventure works, this is also one of the things we can download it, download the images. And now if we want our code to return the position of individual words, so in this case we are again getting one line, and for each line we are getting from the words list, we are getting each word. For each word we are getting the text and the confidence score. So this is also using again a helper function. Then we can just see what is in the helper function. So I hope this makes things clear. Now let's go to our lab and delete all of this, right? And let's paste all of this code here. Now that we know what we are doing, right? So yeah, let me pause the video and paste this code. So I have formatted the whole code. So now let's see what are the next instructions. So first of all, we have to run this code and downloads the lines.jpg. So for that, what we have to run this python read txt.py images lincoln.jpg. So let's run this. So yeah, let's paste this here. Let's close this, control S, control Q, and let's run this. So in lincoln.jpg, we are getting the text. So the text is in this temple as in the hearts of people for whom he saved the Union in the memory of Abraham Lincoln, right? So that was all, uh, you know, in the image. This this is saved in lines.jpg. Then it's the individual word's confidence. So each of this word has a very high confidence of 100%, I think, of 1%. Okay, so confidence is 0.99, 0.991. I think it has not multiplied with 100, right? But this is a very high confidence. So let's see uh, words.jpg. So let's download words.jpg. Okay, the term download is not recognized. Okay, yeah, so this is the spelling mistake. Download words.jpg. Now let's click here and see how it looks. Words.jpg. So as you can see here, so it has tried to draw the bounding box. It's not that perfect, but yeah, most of the things it has done correctly. So each word it has a bounding box here. So yeah, that is the one thing. Now let's see the another one. If it is a sentence, like if it's line also has a polygon coordinate. So in that case, it will look like this. In case of words, it will look like this, right? So next step is to use this for business cards.jpg. So for that also we can try. And then it's for node.jpg. Let's try it for node.jpg because this text is looking very uh, handwritten. So let's try for that. Uh, images node.jpg, right? Let's enter this and let's see. So yeah, text is shopping lists, non-fat milk bread, image lags. Then it has saved in lines.jpg. Then this is the confidence score for each of it. For shopping, it's 96. List is 83. For non, it's very less, 58%. Others, it's very high. Let's see. Download. And the file name is words.jpg. Okay. So words.jpg. Let's download this. Let's click here to download your file. And let's open this. So as you can see here also it has put the words shopping list, non-fat milk, bread, eggs, right? So this is how it's doing. It's working perfectly. Now for the positions of individual words, right? So this is the whole lab. Yeah. Thank you.